In this video, we'll continue our discussions of lines in 3-space. In the next two examples, we'll look to find intersections of lines if they intersect. All right, so determine if and when they intersect. The first thing I need to do for myself, I always check it because I forget to, is we're checking to see if they are parallel. So to check if they're parallel, I'm going to need a v1, which is my directional vector for line 1. Remember, those are the coefficients of our t's. We got -3, 6, and 1. All right. And then I'm also going to do v2. So v2 is 2, 1, 4. And if they are parallel, then there is a c times v1 that equals v2. So c times -3, 6, 1 equals 2, 1, 4. Now, we only have to find one c and then show that it doesn't work for the other ones. I'll set up these three equations. -3c equals 2, 6c equals 1, and 1c equals 4. So we have c equals 4, but notice that c does not equal 4. So that tells me that it's not parallel. I'm going to move this over here because it doesn't really make sense to have it in this corner. I thought it would, but so that implies that v1 is not parallel to v2, which implies L1 is not parallel to L2. Okay, so we showed that they are not parallel. So let's check something else. Now, this does not mean they intersect. What this means is they could be two lines, and we talked about this in the previous video. Think of a highway that's lifted off, let's say in a flat plane, like in XY plane, not on the surface of a sphere, but just in a flat plane. I have a highway running on the ground, and then I have a highway running in a different direction, but that's always 20 feet above the ground. Those two highways will never intersect in my 3 space, but they do not run together. They run like maybe at an X, but one is 20 feet off the ground and one is on the ground, so they never actually intersect. Those are called skew lines. I'll just write it here, SKEW. Check those out. I think we're going to maybe have one of these in an example, but I wanted to point that out. Just because they're not parallel doesn't mean they intersect. Okay, so how we go for intersection. So check for intersection. Spell it right. All right, how we do that is you let x1 equal x2, y1 equal y2, and z1 equal z2. All right, so let's do that. I'm going to create a system here. This is, okay, I need to see the vectors. I got 2 minus 3t1 equals 3 plus 2t2. Don't let the 1s and 2s on the t's throw you off. I'm just using those as subscripts to just keep them different from the line 1 and 2, like to differentiate the two. Right, y's, I got 2 plus 6t1 equals -5 plus 2t2. And then the z, I got 3 plus t1 equals -2 plus 4t2. All right, pick two of these equations. You're going to solve a system. Notice that I have 3 equations, 2 unknowns. I only need 2 of these equations. So let's take, I'm going to, it doesn't matter. I'm going to pick, I guess, these bottom 2. And I'm going to work with those to try to solve for one variable or the other. Okay, so I got 2 plus 6t1 equals -5 plus 2t2. The first one I'm going to times by 1. That's what we did. The bottom one, I'm going to multiply by -6. I'm going to get that t1 to go away. So I got -18 minus 6t1 times 12 minus 24t2. Notice now I can solve for t2 by just adding my equations down. This gets me a -16, and then I got a 7 minus 23t2. All right, I minus 7 from both sides, so I get minus 23 equals -23 t2. So we get actually works out really nice for us. T2 is 1. right? I can find T1 using the equations from above. So I got 2 plus 6T1 equals, and I'm going to plug in T2, which is 1. So I go ahead and solve for T1 now. All right, I minus 2. I go pretty quick through this algebra. I'm hoping you can do the algebra. So this is T1 also equals negative, not also, but equals negative 1. Let me fix that T1 because it's pretty bad. T1 equals negative 1. So now what we do after we get those, let me section this off. Now we check T1 and T2 in remaining equation. Expel it. Remaining equation. Right? If I plug into the remaining equation, remember we used these two. So I go to that top one, 2 minus 3, and I got to plug these in. All I'm doing is checking. If it validates the equation, that's where they intersect. If it doesn't validate the equation, then they're skew lines. All right, so I worked that out. Okay, that is 5 on the left side, and we're still wondering, does that equal the right side, which is a 5? It does, so that means the lines do intersect, and they intersect at t equals 1. So they intersect when t1 equals negative 1. So to find my x, y, and z, I just plug t1 into L1. Okay, L1 is that very top one, it's any of the t1s. So okay, I get x equals 2 minus 3 times negative 1. I'm going to write these down. Y equals 2 plus 6 times negative 1. And then z equals 3 plus negative 1. So the x's, okay, that's going to be a 5 in the x. It's going to be if I plug in negative 1 there, I got negative 4 in the y, and then 2 there. So the two lines intersect at 5, negative 4, 2. The only thing that's going to change is one, they'll either be parallel at the very beginning, and then you stop, right? Because if they're parallel, they don't intersect. What's going to change for us is this step here. If this step ends up not working, then the lines are called skew, which is what I was talking about, where you have like two roads where one is 20 feet always, and one is on the ground, and they run like at an X. They're not skew, they're not parallel because they don't run in the same direction, but they are skew. Okay, I got another example with lines. This one has multiple things we need to answer. When I do this, because I'm very bad at being distracted and answering part of the problem and moving on. So I like to do this. Okay, determine if and when they intersect. That's my problem 1. I'm going to find the angle between the two lines. That's my problem 2. And then also find where line 2 crosses the coordinate planes. It's going to be problem 3. All right, so we'll start this the same way. We got to check to see if they're parallel. So V1 is my directional vector for the first line. Remember, those are the numbers on the bottom. 1, 6, negative 2. V2 is going to be 12. And notice we're missing one there. It's just a 1. It's over 1. And then 8. All right, so those are my two directional vectors. If I want to check parallel, there's a C times V1 that equals V2. So that is, I'm going to go ahead and set this up. That's 1C equals 12, 6C equals 1, and negative 2C equals 8. Well, C equals 12 here, but C does not equal 12 there. Okay, so not parallel. Well, I guess we should follow our logic. This tells me that V1 is not parallel to V2, which implies, should be using double arrows for implies that L1 does not equal L2. Okay, so not parallel. That was part of number 1. So let's put number 1 here so we're keeping track of the numbers. So now, remember I set all my x's equal together, all my y's. Now this one's going to be a bit tricky because we have to set it up as like they are parametric. Okay, so how we do that is we're going to do, okay, so let's do one of them to make sure this is equal to t. So x1 minus 8 over 1 equals t, which tells me x minus 8, x1 minus 8 equals t. And then if I solve for, hold on, x1, yeah. So this is x1 equals t plus 8. Sorry, my brain stopped there. And then the 1 in t, this is going to be like my directional vector. So it's opposite and then directional vector. Okay, so I'm creating my system. Okay, I got t1 plus 8. Okay, that's going to equal 12t2 minus 7. Now my y1s, all right, so y1 tells me 6t1 plus 5 equals t2 plus 3. Actually, this one's a little tricky. Let's look at this one real quick. Take this. Notice it's backwards. So 3 minus y2 is the same thing as negative y2 minus 3. But I could just take that and say, okay, y2 minus 3 over negative 1. Okay, so it's a negative t2 plus 3. All right, and then the z's, okay, this is going to be negative 2t1 plus 4, and then 8t2 plus 14. Take two of those equations, one that we want to, I'm going to take these bottom two, because I can just multiply this one by 8, that one by 1, and not change anything. And get things to cancel out, I mean. Okay, so 48t1 plus 40 equals, okay, negative 8t2 plus 24. All right, and then I do the bottom one times 1. Nothing changes. Notice the 8t2s are going to cancel. So I got 46t1 plus 44. Those are gone, and then I got 38 on the other side. So 46t1 minus 44, that's a minus 6 over here. Ugh, this is gross. Okay, t1 equals negative 6 over 46, which is going to be negative 3 over 23. Gross. Okay, so we're going to plug that in. I'm going to plug it into the bottom equation there. I got negative 2 times negative 3 over 23 plus 4 equals 8t2 plus 14. All right, I'm going to grab my calculator, and I'm going to do a little trick here. If I can find my calculator. Right, I'm going to multiply everything in my equation by 23. So I'm going to get a 6 here. 4 times 23 is 92. 8 times 23 is 184. And then 14 times 23 is 322. I know the numbers got much bigger, but now I don't have fractions. 6 plus 92 is 98. I'm going to minus 322 from it. I got negative 224 equals 184t2. I'm going to divide that by 184. Get me a pretty fraction. It's t2 is negative 28 over 23. Okay, I know it's not ideal to have these numbers, but we still can do it. It's annoying, I get it. So now we have to check t1 and t2 in remaining equation. Okay, that was our top one. So that was t1 plus 8 equals 12, t2 minus 7, and we're going to plug in these nasty numbers. Negative 3 over 23 plus 8 equals 12 times negative 28 over 23 plus minus 7. Okay, so I'm going to do all this in my calculator. I'm going to do the right side first. Times 12 minus 7. Okay, I got on the right side, and remember we're questioning this. I got negative 497 over 23. I'm using my calculator. Negative 3 over 23 plus 8. I got 181 over 23. Those are not the same. So what this means, they weren't parallel. We checked that. This tells me that we have skew lines. So we have three different outcomes. They were parallel to begin with, right? That was the first thing we checked every single time. You want to do that first because it's the least amount of work. Then if they weren't parallel, right, that was this first part here. If they weren't parallel, then we took that next part and we set our each part equal to each other. Now, when they're in symmetric like up here, we're going to need to set each part equal to t and solve like we did in that first equation. Set them equal, pick two of them that you want, work with those as a system, figure out T1 and T2, and then we took that and we plugged that in to check. If they work out equal, then that's where they intersect, and you just plug it back in to find it. If they're not equal, then they are skew lines, which remember is the infinite highway that's on the ground, infinite highway that is 20 feet off the ground, and they don't run together, but they run intersect at a point, right? But they don't actually intersect. They cross over each other. So the two lines run in the same direction, they run like this in three space. I'm looking down on it, but say this highway is 20 feet off the ground the whole time, and the other highway is on the ground. They don't actually ever cross each other, intersect, the highways don't run into each other, but they're not parallel.